Hi, I'm Lee Teschler with Machine Design Magazine. We're here with Rick Wood from Rollon. Rick's going to tell us a little bit about a new telescoping slide design.
Great. Well, the telescoping slide that Rollon has developed actually solves a problem in linear motion that many customers and many companies have run into. What you run into with linear motion is there's always a guide rail that's hanging out into that open space, and so to get that guide rail to clear that space effectively has always been a challenge with standard linear guide products. The Rollon telescopic guide allows us to have quite a bit of extension with very little of mounting space and without a lot of overhang. So we can actually have quite a lot of stroke, but on a very short mounting area. This is good for a lot of reasons because, space is a premium. Also, when you get out of the way, you need everything to be completely out of the way. This isn't, we don't always have the luxury to have a long rail supporting or hanging out into space and then have this door slide across it. So the Rollon telescopic guide gives you a couple of different really good options. Number one, it's very robust. It's a very high load capacity product. When you're, say, like in some of the cases we have, like operating on a train or a big truck, we can have a telescopic slide out that when nested is going to be exposed to a very high vibration environment. But then when it needs to come out, it has to operate smoothly, but then it has to go back into that very high vibration environment again. And so the ability for some of the telescopic slides to handle both the high vibration as well as the slide out and the high load capacity. Sometimes we're seeing 1,000 pounds being telescoped out, serviced, and then put back. And we're doing that. Rollon can do that with very minimal deflection compared to other guides that might have a very strong, very big deflection when it's out on its end and will cause even binding.
How is the slide put together?
The slide's put together. This is a steel frame with another slider inside and balls in between, and so there's a captive cage. But you're dealing with steel balls, steel guide, outer guide, and steel inner guide, and so that gives a lot of the robustness, and it becomes a structural element of your machine and your slide, along with the other part of your framework.
How does that differ from competing slides?
Rollon is unique in that we occupy the space, the design space, in the very high and the very robust application. So when you're dealing with high load capacities or high load requirements, Rollon seems to be the only solution. The other competitors we have on telescopic guides, they're not as robust. They're not dealing with, they're good for what they do, but when you get past 10 or 15 pounds in a drawer, it gets really difficult. So when you're talking about a drawer slide or a telescoping thing that's in the hundreds and thousands of pounds, then Rollon becomes the only choice available.
Mechanically, how does standard slides differ from this design?
Sometimes people are using just standard rollers, and that's, again, having a bunch of balls in a row and then the guides overlapping each other gives us a lot of stiffness. A bunch of balls in a row is a more robust area than if you put a couple of wheels or a couple of rollers and having that cantilevered out.
Are there any application guidelines you can give for this?
Lubrication is always a key when you're dealing with metal parts and non-friction rolling elements. Figuring out how to manage the lubrication. Sometimes people choose to go without lubrication because of the mess involved, but without lubrication, that's always going to reduce the amount of material life that you're going to end up with. We do have, certainly straightness and alignment is always a key. We have a lot of forgiveness for alignment. So some of the other ways of doing it, you might have to be a little more precisely aligned, but typically, paying attention to your alignment is usually pretty good, and also paying attention to your stops. Sometimes just jamming against the stops all the time couldn't cause a problem, so you may have to engineer some way to stop the travel where you need to stop it rather than relying on the guide to stop the travel.